Okay, 3.5 quantum numbers. Okay, what are the quantum numbers? So it's like a fingerprint, the quantum number of fingerprint for electron. Any electron inside the atom has its own quantum numbers. Quantum numbers consist of N, L, ML, and S. So here, the first quantum number is energy level. The electron could be at a very close distance to nucleus at energy level 1, or it could be higher, energy level 2, energy level 3. So when it's very close to the nucleus, it is kind of bounded into the more bounded, so it's less energetic. If you go to the higher energy level, it's more free, so it's more energetic. Anyway, so it is start and start with 1, 2, 3, and 4. So the second quantum number is L. So quantum number L is the shape of the orbital. So we could have a spherical shape, a dangling shape. Just gonna see if there is any. Okay, we'll just do that here. So here we have a spherical shape, which we call it L0. Or it could be L1, this dangling shape. It could be L2, is more complicated. So if it is L0, we call it S orbital. If L is 1, we call it P orbital. L is 2, we call it D. And so on. The next one is G. And sorry, is F. L4 is G. Here in the textbook, you just have until G. Now, what is the relationship between the L and N? So L, I'm just going to do a different color. L is from 0 to N minus 1. This is for L. For example, if N is 1, what is the L? L gonna be from 0 to N minus 1. N minus 1 is what? N is 1, is 0. Basically 0, 0 to 0. 0 to 0 is just 0. So in a first energy level, you just can't have a shape of our orbital can just be the spherical. When N is 2, the L is 0, N minus 1, 2 minus 1 is 1. So it could be 0 or it could be 1. If this is 0, is a sphere. If this is 1, is dangling. So you could have 2 energy levels. And so on. For 3 and 3, L gonna be 0 from 0, 1, 0, 1, and 2. Anyway. How about M of L? M of L is orientation. Orientation. For example, when your L is 0, the M of L just have one orientation, right? It's just, you look at the sphere at any angle, it looks the same. So ML is 0. If this is dangling, Because see, your dumbbell could be in x-axis or y-axis or z-axis. This could be in z direction, or it could be in x direction, or it could be in y direction. Look at 3D space, right? So I'm just gonna put that here, guys. Here, the dumbbell could be in a z direction, or it could be in y direction, or it could be in x direction. So it's a 3D. So that's why here, this middle one is gonna be 0. Here m is gonna be -1. And here m is gonna be 1. Okay, we have 3 of them. If you want to come up with a general rule, m of l is from -L to L. Okay, I'm going to give an example. Say L is equal to 0, then m of L is what? Is from -0 to 0. -0 to 0 is just 0. If L is 1, m of L is equal to -1, -L to L, -1 to 1, -1, 0, and 1. If L is equal to 2, m of L is -2, -1, 0, 1, and 2, and so on. You can do that. Again, N is energy level, L is shape of the orbital, M of L is orientation. So what is the speed? We call it M of S. M of S, so a speed, it could be up or down. It could be +1/2, speed up, or it could be -1/2, a spin down. So it's just a rotation, the direction of the rotation of the electron. So for this, you can fill question number, like table 3. That part is page 182. Here they talk about M of L. And look at this chart. Talking about M of S here. Yeah, look at this table. So you can do question number 3. Question number 5. This page 184.